Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge for March. So design browser history. So what this problem says basically is that we want to implement a browser history class where we start out with a home page and we can visit a URL. We can get back in the history, so like back button with a browser. And you can move either back, and once you move back, you can also move forward. And in both directions, you can move any number of steps. And so this class will have, of course, the constructor that gets passed the initial home page. And then we need to call visit when we want to visit a URL. And this needs to clear up the forward history, right? So basically, when you visit a new page, let's say for example, here we pressed back a couple of times, and then we completely copied a new URL to the browser window. That needs to clear up everything that was forward, which makes sense, right? And then we have a back function that goes back a number of steps. Now, if, let's say, you can go back only 2 steps, right? Because in the stack you have only 2 web views or 2 URLs. Then if the steps are 3, then we go back only 2 times because we don't have enough for steps, right? So it's sort of the minimum of what's available in the steps here. And then you can also go forward, and similarly for forward, if steps is bigger than how many you can go forward in, we will just use that. Basically, let's say if it was X, then we'll just use X. So that's the idea. Now, yeah, so pretty much like just a simple browser behavior. Okay, so how can we solve it? Okay, so how do we handle this? Well, you can notice here one thing we are doing is that we visit pages, right? And then, so for example, we visit Leetcode, and then we visit Google, and then Facebook, and then we want to go back, and so we go back to Google, right? And we display google.com, and then if actually we visit YouTube, and then we get back, and so we go back to Facebook, and then we get another back, so we go back to Google, and now we get forward, and so forward we get back here, and then we get another visit to visit LinkedIn, and so now LinkedIn is the top one and YouTube is removed. And so after that we get forward, and so from Facebook we go forward, which is now LinkedIn, right? So this one is now pointing to LinkedIn. And then we get back, and so we go back to Facebook, we display Facebook, and then we get back again, we display Google, right? And so just from what we are doing, what I did here, right, what you can see is that this is really the behavior of a doubly linked list, right? The only thing we need is that when we get forward, we want to go forward to the next node, and then when we get back, we want to go back to the previous node, right? So if we can construct the visits as sort of a doubly linked list, then we can easily do forward and backwards, right? And you can see also the part where when we were here and we got to visit LinkedIn, we wanted to get rid of this YouTube. Well, that can be done by just changing the pointer for the next node, right? That's the only thing we need to do. So this tells us that actually it's easy to implement this with a doubly linked list. Definitely you can do it with a dynamic array or stack, but it's like right there, it's an application of a doubly linked list because of how easy it is to use it. Okay, and so what does that mean? So basically when you visit, let's call this Leetcode GFY, and then this LinkedIn, right? So what we'll do is first when we initialize with the home page, we'll just have L as for Leetcode. And then we visit Google, and so we'll just point the next to Google, and then point back the node to Leetcode, right? And so this can be just done by a list node, that data structure that has both the value that has the URL, and then the next node, and then the previous node. And we can just point it, basically say list node of L.next is going to be the list node for G, and then previous for G is going to be the list node of leetcode.com, right? And then when we visit Facebook, this is going to be facebook.com. By the way, I'm just giving you a representation of it, and then the back pointer will point to this here, and then when we visit YouTube again, the back pointer will point to Facebook. Okay, and now after we do all these 1, 2, 3 visits, so 1, 2, 3 visits, we get back. Okay, now the current node, we will need to maintain our current node that tell us where we are at. Now our current node here is pointing to YouTube, right? And so when we get back, we will say, we'll move it back, so it will now be pointing to Facebook here. And then when we get another back, right, it will point back to here. So now our current is here, right? And then when we get forward, we will move our current to current.next, so it will point here, and of course it returns facebook.com. And then when we visit LinkedIn, right, now current is here, so we want to change its .next, so we remove it from here and we say its .next is now LinkedIn. Okay, and then the previous is going to be this one. We don't need to get rid of this because this one we won't touch it again anyway, right? And so now when we get forward again, our current pointer is at LinkedIn, right? Because every time we insert, we move it. And so when we get forward again, so when we get back after forward, we go back to Facebook and we return Facebook. So yeah, pretty much just exactly what the problem says. It's just that when we get a visit, we want to create a new node and attach current.next to that new node with the URL. And then we want that new node here to have its prev pointing to current. Okay, so that's pretty much the idea here. We'll implement them in more details, but this is the concept. Just create a list node with a doubly linked list with next and previous. And when you insert, both make sure you add the next pointer and the previous pointer. And keep current to maintain where the pointer is at any moment in time as we do back and forward. And that should be it pretty much. Okay, so let's implement the logic we saw in the overview. So first we need to create a node for our doubly linked list. So we need a list node, right? And then we need to define its initialization function. And that function will need a value. It needs next and prev, and let's just by default set them to none. And so what will happen here is this is going to be self.val is going to be equal to that value, self.next is going to be equal to next. Let's just call it this to avoid conflict, and then previous is going to be equal to previous. Okay, so that's the node. Now we need to define our current, which is going to be equal to list node of the home page. That's the first node. There is nothing previous to point to for now, so we just keep it like that. And now when we visit, well, we want the current node where we were with the previous page we visited. We want its next to point to the new node with the new page, right? Because the previous one is going to be in the back history. And so this is going to be a new node with this URL. Let's actually just call it a new node and define it, right? Okay, and so new node.prev needs to be equal to the current, right? So let's actually do it like that. And the current next we need to point to the new node, right? And so here actually an easier way to do it is just to say prev is equal to this, okay? And then the current node next is going to be this new node, right? And then we need to move the pointer so that next time we visit, right, we add the new page, right, after this one. So that's why we are doing here. We are doing this here. Now to make this shorter, we can just put the new node here. I just wanted to do it for the sake of understanding earlier. Okay, so that's for visiting. Now, how do we go back? Well, we can just use the previous pointer to keep going back until we go back the number of steps required. Or if the linked list is done, we stop, right? And so to do that, well, we'll do while there is somewhere to go back to. So while there is a previous value. So this will take care of, like, if the number of steps is bigger than what we have in the history, we will stop because of this. And the steps is still bigger than 0, right? We want to go back which means basically doing self.current is equal to self.current.previous. So we go back. And then we decrement 1 from steps because, so that, yeah, we want to go, let's say 2 steps. When we go back once, we decrement by 1. And then when we go back another time, we decrement by 1 and we'll reach 0. Okay. And then what we want to return is self.current.value because that's where we want to go 2 steps. And then after 2 iterations from here, we'll be at the desired node. And so we just return its value. Okay. And now to do a similar thing for self.current to go forward, well, we want to keep going forward as long as there is somewhere to go forward to, right? And so while there is a value and so while there is a value to go back to, we'll keep going and then end. So exactly like a similar to here. End steps is bigger than 0. We want to keep going forward. Okay, so self.current.next, and then steps -1, and then once we reach the node we want to go forward to, we can just return its value. So that would be self.current.value. Okay, and that's pretty much it. So let's run this, and let's submit it, and that passes our test cases. Okay. And in terms of time complexity for this, let's look at the operations for each. Well, the constructor does just 1 operation, so it's just O of 1. This is time. Now, what about the visit? Visit is also O of 1 because we are just creating these 2 iterations. They are constant. Now here, however, the go back, if we have the number of steps are as much as the length of the linked list so far, then it's going to be O of n. So here, worst case, it's O of n time. It can be bigger than that because we stop when the list ends, right? And similarly for forward also, we stop when the list ends, right? With this. And so at most, it's going to be O of n being the number of pages we get, right? And that's pretty much says that basically O of n for back and forward, and then O of 1 for visit. And yeah, so that's pretty much it for this solution. Really easy to take advantage of doubly linked list and use it here. You could also use a list, but it's a little bit trickier to maintain the pointer with a dynamic list. Yeah, so that's pretty much it. Thanks for watching and see you on the next one. Bye.